Hello everyone, welcome back. Hope you are doing good. Let's proceed with the playlist in which we write the Python program from the practical list. In this video, we are going to write the code to calculate GCD and LCM of two integers. But before writing the code, let's understand what is GCD and LCM. We have already studied it in maths, but let's recall it once again. GCD means greatest common divisor. It is the highest number which will be divisor for both the numbers. There are actually two different methods to calculate GCD. We have studied this method. It is known as prime factorization method, in which we find out the factors and we multiply the common factors from both the numbers. So that will be GCD of both the numbers. There is one more method. It is known as Euclidean algorithm. What we will be doing? We need to simply use this formula. The value of A will become B and the value of B will become A mod B. This formula we need to keep on repeating until the value of B becomes 0. Ultimately, when the value of B becomes 0, the value of A is the GCD of two numbers. But before directly writing the code, let's understand the logic and dry run it. For that, we are taking two numbers. The variable A is nothing but number 1 and variable B is nothing but number 2. Why we are assigning this value to A and B? We cannot directly work on the numbers, that's why we are initializing it. Because in the algorithm, these values are gonna change. Here is the dry run table. Let's try to understand the values in each pass. According to the algorithm, this is the value of A and here is the value of B. A is equals to B means we need to assign 16 to A. Now what is the value of B? It is nothing but A modulus B. A is 12, modulus B is 16. When we divide 12 by 16, we will get remainder as 12. Alright, let's proceed to the second pass. Now the value of B is 12. That's why we have initialized it to A. What will be the value of B? A is nothing but 16 and B is nothing but 12. Now you know when we divide 16 by 12, what we will get? 12 ones are 12. The remainder will be 4. So here is the answer for this expression. This process will keep on continuing until the value of B becomes 0. It means we need to proceed to the another pass. Now the value of B is 4. So it will get initialized to A. Now A modulus B means 12 modulus 4. 12 is completely divisible by 4, that's why the remainder is 0. This is nothing but the value of B. Look at the loop. Now loop will not execute because the value of B becomes 0. Alright, the execution is done, but what is the value of GCD? GCD is nothing but the value of A. It means 4. Now do one thing. Pause this video and try out the prime factorization method to calculate GCD and let me know whether you are also getting the same answer or not. Alright, with the hope that you understood the logic, let's write the code. For that, one gcd.py file is ready. Let's close the Explorer and start writing the code. We know the first step is to take input. We need two numbers. So here is the number 1. Enclose input function in integer function. Let's write the message. Enter first number. In the same way, we will be taking the second number. Change the variable name as well as the message or the prompt. We cannot work on the actual numbers. That's why we are initializing it to variable A and B. A will get initialized to number 1. In the same way, we will initialize B to number 2. So here is the number 2. Alright, now loop we need to execute until the value of B becomes 0. For that, we can simply write B. While B means until the value of B is true and the numbers greater than 0 considered as true. If you are getting confused, you can simply write while B is greater than 0. When it will become 0, 0 means false. Then loop will stop. There is one more option you can write clearly while B is not equals to 0. Now inside the loop, we have to just write the Euclidean algorithm which says A will be B. And what about B? B will be A modulus B. So let's write it. A modulus B. Now what will be GCD? GCD will be A. For that we have taken the variable GCD itself. Using print statement, we are going to print the message. To format, I am using F string. GCD of, let's use placeholder to write name of the variables. We are calculating GCD for number 1 and number 2. So GCD of number 1, and here is one more placeholder for number 2. Let's continue the message is. GCD we got in variable named GCD itself. Now let's execute and check the output. Let's enter the same numbers 12 and 16. Look at the output. We got the correct GCD. GCD of 12 and 14 is 4. In this way, first task is done to calculate GCD. Now we need to calculate LCM. Hope you know the LCM also. LCM is nothing but the smallest multiple of both the numbers. If we take same numbers, first we need to calculate the multiples of 12. It will be 12, 24, 36, 48, 60 and so on. Now let's calculate the multiples of 16. 16 ones are 16, 16 twos are 32, 16 threes are 48, 16 fours are 64. In this way we can calculate. But now we will stop calculating multiples because we can see the common multiple from both the numbers. In this way we got the smallest common multiple from both the numbers. It is nothing but 48. So for these two numbers, LCM will be 48. If we have already GCD, we can use this formula to calculate LCM. Look at the formula. This is nothing but absolute value of A multiplied by B divided by GCD. This AB refers to the original number, that is number 1 and number 2. Alright, we understood it. Now let's code. Let's take the same variable. LCM equals to, we will be using absolute function. We will be using the original numbers, not the calculation of AB, because you know B is 0. So we need to consider original numbers. Number 1 multiplied by number 2. This term is divided by GCD, which we are getting in a variable named GCD itself. Alright, calculation part is over. It's time to print. Let's copy the same statement and change it. Instead of GCD, we will be writing LCM. The variable name is LCM. Let's execute the code and check the output. I am going to enter the same numbers because it is easy to cross check. First number was 12 and the second number was 16. Look at the output. The GCD we are getting 4, that is correct. Even LCM is also correct, but we are getting the answer in the form of float. Then one thing we can do, let's change it to floor division. Now we will get the answer in the form of integer itself, because floor division gives the answer in the form of integer. Let's enter the same number 12 and 16. Here is the perfect output. We got GCD as well as LCM. Hey, that's a wrap for today's video. Hope you enjoyed writing code. If so, share it with your friends. In the next video, we need to write the code to count and display the number of vowels, consonants, uppercase letters and lowercase letter from the string. So until next time, stay curious, stay tuned. I will see you in the next video.